Welcome back again. We are now working on part 4 of our quarterly assessment review. And in this video tutorial, we're going to talk about the discriminant and the quadratic formula. The discriminant, remember, is part of the quadratic formula, and it enables us to determine the type of roots we can expect to have when we solve the equation. It'll also help us determine how many solutions we should expect to have. So we're going to scoot on over to problems 4 and 8 from the review guide. Number 4 is a non-calculator question. Number 8, you can use your calculator. Before we do that, though, let's just review what the quadratic formula is. As long as our equation is written in standard form, where we have ax squared plus bx plus c, and that is equal to 0, then the quadratic formula basically states that we can take the opposite of b, plus or minus, the square root of b squared minus 4ac over 2a. And when we simplify that expression, that'll enable us to determine the roots of our function, whether they're real or imaginary. Now, we also spent a little bit of time talking about this quantity underneath the square root. That is called the discriminant. And the discriminant tells us the type of roots we're going to have. When you take the square root, think about it. If you take the square root of a positive number, we can expect 2 real roots. And think about the formula. There's a plus or minus in there. So we know we're going to have a positive root and a negative root. If I have plus or minus the square root of 0, if my discriminant is 0, then I know that because the square root of 0 is just 0, I know there's going to be 1 real root. And we'll eventually learn that that's considered a double root. And if I have plus or minus and what's underneath is a negative number, if my discriminant is negative, then I say I have 2 non-real. Sometimes you'll hear them called complex or imaginary roots. Okay, and so the discriminant is just the quantity underneath the square root. It's just that b squared minus 4ac. 2 real roots mean that I have 2 x-intercepts. 1 real root means that I have 1 x-intercept, and it means that the vertex is the x-intercept. And then if I have 2 non-real roots, that means there are no x-intercepts. Okay, so that's what it would look like graphically. So let's take a look at the first problem. It says, suppose the functions f and g are to be graphed on a coordinate plane. Complete the table below by answering each question. Well, first of all, we're asked to find the discriminant. Now, the discriminant is just b squared minus 4ac. It's just that quantity underneath the square root. It doesn't include the square root symbol, though. So in order to evaluate that, it sometimes helps to identify your a, b, and your c values. So for f of x, my a value is just 1, my b value is 3, and my c value is negative 4. So I'm just going to plug these in, and I want you to get in the habit of using parentheses to replace your variables. So now when I plug in 3 for b, and 1 for a, and negative 4 for c, 3 squared I know is 9, and then if I have negative 4 times 1 times another negative 4, this is going to end up being plus 16. And 9 plus 16 is 25. In the second part, it says, what does this value tell you about the graph's intercepts or roots? How many are there, and are they real or imaginary? Well, since this is a positive number, think about in the formula, I'm taking the square root of 25, and since I'm looking at both the positive and the negative root, I know I'm going to have 2 real roots or 2 x-intercepts, if you'd rather look at it that way. And so this gives me the number of roots, this gives me the nature or the type of the roots. Let's take a look at g of x. And again, it'll help to identify your a value is 2, the b value is 4, and the c value is 5. And so if I put in my parentheses, it's going to be b squared minus 4 times a times c. And then I can plug them in. So b squared, that's a 4, minus 4a, which is 2, times c, which is 5. I know 4 squared is 16. And then if I look at the next quantity, I've got negative 4 times 2, that's 8, or negative 8 times 5 is negative 40. And if I combine those, I'm going to get a negative 24. And so since that is a negative value, I know that what's underneath the square root then, think about it, is going to be a negative 24. And when I take the square root of a negative number, I know I'm going to have an imaginary root. This plus or minus tells me that there's two of them. I'm going to have plus something I and minus something I. So there are two imaginary roots. And if I have two imaginary roots, I will not have any x-intercepts. Okay. In number 8, it says to determine all of the roots to the equation 2x squared plus 3x plus 5. Now, you can try to use a calculator here. It's kind of unfair, I think, that it's on the calculator section because, honestly, if you graph it, you're going to find that the quadratic equation has no x-intercepts. So you'll have to use the quadratic formula here. And again, let me go back to what we showed you before. The quadratic formula is simply negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm actually just going to copy and paste it on this page. Now, for those of you that have your foldable, this would be a good equation to write down. Now, I've just replaced all my a, b's, and c's with parentheses so I don't forget. But the formula is, again, x equals. Think of this as the opposite of b plus or minus the square root of b squared minus 4ac. We're familiar with that expression now. All of that is over 2a. And so if I want to solve this equation, notice it's in standard form for me. I'm just going to type in or let a equal 2. b equal 3, and c equal 5. And so in this first set of parentheses, that's where my b value goes. In this set of parentheses, my b value goes there as well. And then it's minus 4 times a times c, and all of that goes over 2 times a, which again is 2. When you're simplifying an expression like this, simplify each part separately. So, for example, I'm going to separate this from what's underneath my square root from what's on the bottom. So if I think about the opposite of 3, that gives me a negative 3. Plus or minus, I'm going to keep the square root there and just simplify what's underneath. I've got 3 squared, that's 9. And then I've got minus 4 times 2, that's 8, times 5 is 40. So I've got 9 minus 40 is a negative 31. And all of that is over 2 times 2, which is 4. So when you're thinking about simplifying this, the only thing I can really do is pull that negative out of my square root. And so it's going to end up being negative 3 plus or minus. Now, the square root of 31, that is not a perfect square. And so I'm just going to leave it as the square root of 31. But my I comes out now. And all of that is over 4. But remember, the plus or minus, this is just two different ways of writing the equation. If I divide both parts by 4, you might see the solution written this way, where it's negative 3 over 4 plus or minus the square root of 31i over 4. And then if it's possible to simplify either of those fractions, you want to go ahead and do it. I think this is a multiple choice question. So you might also see it where we have negative 3/4 plus the square root of 31i over 4, and then the other solution would be negative 3/4 minus the square root of 31i over 4. And so that also reinforces that there are two roots, and because they both have an I in it, they're not real. All right, we have one more question to go, and that'll be on the next video.